The world's population exceeds 7.89 billion people and encompasses 195 nations, which intricate interaction of socio-economic forces, political dynamics, and disparities in resource distribution that reveal the hidden nuances of hunger impacting diverse parts of the world. As the world experiences technological advancement, the world hunger issue serves a huge population endures the terrible reality of food demand, insecurity, and malnutrition. 783 million people are starving because of a lack of enough food and protein sources. According to animal food consumption data for the United States in 2019, the usage of animals for food production such as cattle's meat is in high demand and making animals breeders fearful that their stock of animals is depleting. Furthermore, as seen by the video, the quality of conventional meat in nations with limited food resources is worse. In today's technologically advanced society, the process used to make ordinary beef emits harmful pollutants such as carbon dioxide, sulfur, and carbon monoxide. Because of gas pollution, this contributes to climate change and global warming. According to the data, the United States produces more greenhouse gas emissions than other countries such as Asia. Aside from determining who should contribute the most to carbon reductions, analysts said that not all nations can be held equally accountable and that economic strength and riches should be considered. Clustering nations by income group from the data reveals a link between higher income levels and higher median emissions per capita. Biotechnology's innovative use of catalysts in bioreactors can address food sustainability by promoting efficient synthesis of ground meat. Israeli food technology startups are pioneering this method, demonstrating the potential to scale production while addressing environmental issues. This technology represents a paradigm change in meat production, reducing pressure on natural resources and environmental degradation. By 2050, the world's hunger crisis can be addressed through lab-grown meat production, meeting consumer demand and promoting environmental care. Ethan Brown and Patrick O'Reilly Brown, founders of Beyond Meat and Impossible Foods, have shifted their focus to plant-based meat due to the food system crisis. They argue that animal agriculture has a larger greenhouse gas footprint than all other forms of transportation and that meeting the Paris Climate Agreement goals requires a significant reduction in animal agriculture. Engineers are working to align meat production with green technology goals for 2030, particularly in bioreactors for meat cultivation. The production of greenhouse gases in these bioreactors is linked to the composition of growth media known as basal media. To address this issue, engineers are exploring ways to dilute nutrient concentration, especially in medium-high concentrated basal media. Meticulous control of temperature emerges as a central strategy in this process. Mary-Laure Collinet, a senior bioprocess application scientist at Citava, emphasizes the temperature's critical role in cell viability. Extremes, especially temperature above 38 degrees Celsius, can swiftly impact cell survival while lower temperature may slow cell growth. Striking the right balance is imperative, aligning the temperature with the medium-high concentration of basal media fed into the bioreactor. Lab-grown meat production begins with a bioreactor, followed by centrifugation and depth filtration. Virus inactivation capture chromatography, and low pH virus inactivation ensure quality and safety. Polishing and nanofiltration are then used. The bioreactor needs enhancement to reduce greenhouse gas emissions, increase meat quality, and maximize production rate. Oxygen enhances cell growth and respiration. The integration of precise temperature control, nutrient dilation, and overlay gas technology in culture meat production can significantly reduce its environmental impact. This technology contributes to a green technology master plan promoting a sustainable environment. Lab-grown meat, unlike conventional meat, produces less greenhouse gases. However, shear stress can affect the viability of cells in bioreactors, affecting the quality of the meat. Engineers must continually optimize process parameters to customize the quality of lab-grown meat, as excessive shear stress can harm or disrupt cells, lowering overall quality.